Hello everyone, welcome to today's presentation. In today's presentation, we are going to calculate the perimeter of a composite figure. A composite figure is a figure that has several regular shapes that have been merged together. Looking at the figure that we have been provided with, it has a semicircle, it has a rectangle, and it also has a triangle that has been merged together. So to calculate the perimeter of this shape, we will be expected to calculate the distance round the entire shape. So we can label the points as point A, and this vertex we can call it point B, and this vertex we can call it point C, and this vertex we can call it point D. So to get the perimeter of this shape, we will be expected to add the distance between A and B, the distance between B and C, and the distance between C and D, and go around the semicircle and add the distance between D and A. So in our case here, we let P be the perimeter of the shape that we want to calculate, and P here will be equivalent to the distance between A and B, which is on a straight line. Then add the distance between point B and C, which is again on a straight line, and then add the distance between point C and D, which again is along a straight line, and then finally add the distance between point D and A, which is along a curved line. Point D to A, which is along a curved line. So we can substitute in the values, and in this case we have the distance between point A and B is 10 centimeters plus the distance between point B and C has not been provided, and as such we will need to calculate this distance between point B and C. Since we know that this is a triangle, we can excise the right angled triangle from the figure that we have been given. Now once we have excised that triangle, we will need to find the distance between point B to a new point here, which we can call this point E. Now referencing to the properties of a rectangle, we know that two opposite sides of a rectangle are equal. So the distance between point B and E will be 3 centimeters. And we can call this distance equal to B. And then we need to find the distance between point E and C, which we can call the adjacent distance with a small letter A. And this will be given by finding the difference between the length D and C and the length A and B, since if this is a rectangle, we know that two opposite sides of the rectangle are equal, and as such the distance between point D and E is equivalent to the distance between point A and B. So as such this distance becomes 10 centimeters up to that point, and this becomes that distance. So the difference between these two distances will give us the remaining distance between point E and C. So we know that A would be given by the entire distance which you've been given, which is 14 centimeters, minus the known distance, which is 10 centimeters. And this gives us the value for A as 4 centimeters. Now, having known the two sides of a triangle, we can now use the Pythagoras theorem that states that the unknown distance, which in this case is our hypotenuse, we can call this point C, would be given by finding the square root of the squares of the other two sides. So we know that C squared, from the Pythagoras theorem, C squared would be equal to the distance of the adjacent squared plus the distance of the perpendicular height squared. So in this case, this would give us A squared plus B squared. But since we want to get the value of C, we will need to take the square root on both sides. So we find the square root of C squared and at the same time find the square root of the other two summed distances square root. So this would mean that our C would be equal to the square root of A squared plus B squared. So we can substitute that value into our expression, and the distance between B and C would be the square root of A squared plus B squared, plus now the distance between point C and D, which is equal to 14 centimeters, plus the distance between point D and A through the curved line would be obtained by finding the circumference of a semicircle, and we've been given the value of the pi here as 3.14. So in this case, we'll have the circumference of the semicircle will be a half multiplied by pi, and then the diameter, which in this case is 3 centimeters. So let's simplify our expression. We'll have 10 centimeters plus the square root of the value for A is 4 centimeters plus the value for B is 3 centimeters. Each of these squared, and then plus 14 we know, plus a half, pi is 3.14 times the diameter is 3 centimeters. Upon simplification, we can add 10 centimeters to 14 centimeters. This would give us 24 centimeters plus the square root of 4 centimeters squared is 16 centimeters squared plus 9 centimeters squared, plus we can simplify what is inside the bracket. So cancel here by 2, you get 1. Cancel by 2, you get 1 point. We have 5, 7. So we will need to simplify the expression 1.57 times 3 centimeters. So this will give us 24 centimeters plus 16 plus 9 gives us 25. So we'll have the square root of 25 centimeters squared plus 1.57 multiplied by 3 gives us 21, carry 2, we have 15, we have 7, and then we have 4.71 centimeters. So we continue simplifying our expression. We have 24 centimeters plus the square root of 25 is 5 centimeters. 5 centimeters plus 4.71 centimeters. So we can use the long addition approach to add all these values. In this case, we'll have 24.00 plus 5.00 plus 4.71. Then you add all this. This will give you 1, get 7, you get 4 plus 5 gives us 9, plus 4 gives us 13. This gives you 3. So our answer now becomes 33.71 centimeters